This topic today will be on superposition theorem. Okay. For this superposition theorem, the theorem simply stated that if you have a linear circuit, okay, and you have more than one sources, can be either dependent or can be either independent or independent voltage source or current source containing multiple independent sources, okay, right? And you need to find some value, some voltage or current in some part of the circuit. In this case, one way to do it is that you can get your answer, final answer, by calculating the algebraic sum of each source or voltages contributed by each source acting alone. Okay. So what it means is, let's say if you have 3 sources, okay, you can take one source at a time, okay, analyze the problem with that one source only, turn off the other sources, another 2 sources, okay, then get the answer, okay, then keep that answer first, then you go to the second source, turn off the other 2, okay, find your answer, go to the third source alone, turn off the other 2 again, and then find the answer, and at the end you add all the 3 answers up, and that's your final answers for the problems. Okay, so you can solve the problem by each source acting alone and then add them together. Okay, so the steps are okay, so you take one source, it could be your voltage source or current source, whatever, okay, and then to turn off the other sources in your problem is that if those sources are voltage source, you short the voltage source, you short them. If those other sources, okay, are current source, you open them up, okay, then you proceed with finding the current or voltage that you want, okay, acting on that source alone. Okay, then you go back. The third step is that you keep the answer from number 2, right, from that source that you have been analyzing. Go to the next source and do 1 and 2 again. Okay, and the final until you finish you go around with all the sources. Then you find your current or voltage by adding all the values of each sources up. Okay, so simple example here. Okay, let's say that I have this problem. They both contains voltage source, current sources. Okay, and you want to find the current through the 100 ohm. So I want to find this current. Let's call it IL. Okay, it's called IL. Okay, of course you can use mesh, you can use nodal analysis, whatever you feel comfortable. Okay, but I'm telling you that there's another way of doing it also, and this is to do it with superposition theorem. So I'm going to take one source at a time. Okay, so I'm going to keep IS2. I'm going to keep IS1, okay, and since I'm going to keep this one first, right, 0.1 amps. Well, the other source in the problem in the circuit is that it's a current source also, okay, so therefore I have to open it. So open IS2. To open it, I said before that you simply take it out, and it becomes open like this. So this is when you open your IS2. Okay, take it out. Okay, so now you analyze. So let's call it IL prime, meaning that this answer is due to the 0.1 amps only. Okay, so therefore this is a source, so you analyze the problem with 0.1 amps as a source. So it goes up here. It cannot go up here, right? It's supposed to split in a way. Hold on. The current comes to this junction. There are 2 ways, supposed to split like this and like this. However, in this case, it doesn't split, right? Because this is open already. When it's open, the current cannot flow through. So therefore, there's no current flowing through in this branch. Okay. So therefore, all the 0.1 amps go through here, and it go through the 100 ohms. Okay. So your IL prime, okay, I say I1. Okay, I1 is equal to 0.1 amp. So IL prime is 0.1 amp in the purple color thing. Then you go to the second source. Okay. Now the second source happen to be current source also, so you keep the second source, but the first source is current source, so you open it again. So you take the IS1 out, you get this picture. Okay, so therefore, well, the problem said this is IL, right? IL double prime. It means that, for me, it means that it's the answer when source number 2 is used for analysis. Okay, so therefore, take it out. So look at the source, IS2 come like this, 0.03, right? Yes. Boop. Come here. Well, it does not go here, right? Because it's open right here. So therefore, everything goes into here. So, but what happened is that it go in the opposite direction as what I want, IL double prime. So therefore, my IL double prime is equal to minus 0.03 amps, like this. So you get these two answer. This is due to IS1. This is due to IS2. So at the end, your final answer would be the algebraic sum, the sum of the two IL. So therefore, it's IL prime plus IL double prime, right? So equal to 0.07 amp, like this. So 0.1 plus minus 0.03 amps. So this is source transformations. Okay, let's see if there's another example. Let's look at this example. This example right here. Okay, we want to find I that pass through R2, the red current. Okay, we have two sources this time. They are both voltage sources, VS1 and VS2. So first step, I'm gonna keep, see, I can choose VS1 or VS2 first. I'm gonna keep VS2, the 5 volt, right? So to get rid or turn off the other sources it's a 10 volt voltage source, so I have to short it. So short it, right? Take it out and draw the wire. So we short this like this. Okay, so it becomes short like this. Okay, your 10 volt. So now you have, this is the circuit that you have to analyze. Well, to do this, well, I realized that, okay, let's see, how would I find I2 prime? Well, the current has to come from the source of the problem. So 5 volt is the source, the only source too, right? So the current come out from the positive side of the source. Okay, go here, draw it, draw it out. Try to understand how does the current flow. Let's call this I'm going to call this I total. Okay, goes here, right? And then it's split into here, right? I2 become I2 prime and into this line, this branch. Okay, so in my case, I go, okay, I2 prime, it's split, it divided out from I total. So I know that, okay, I2 prime is part of I total. I'm going to use current divider, right? So therefore, my formula I2 prime would be equal to, right? Well, the formula is Ix equal to R total over Rx times Is. Okay, so in this case for me, I2 prime, well, I2 prime divided out from I total. So this is my I total. Okay, my Rx is of course 100, right? Because I2 prime passed through this R2, right? R2, which is 100. Okay, and R total is the total resistance that I total has to split into. So in this case, I total split into this 100 ohms and this 100 ohms, and they are in parallel. They're in parallel. So it's 100 ohms parallel with 100 ohms. So this will be my I2 prime. Okay, my I2 prime. Well, the thing is, I still don't know what my I total is, right? I total, I don't know. If I know I total, I would get all the answer, right? So this is 100 parallel, 100 is 50 over R2 is 100 multiplied by I total. This is I2 prime, right? So the only problem now is what's my I total. So to find I total, right? I total is of course the current passing through the 5 ohm. So Ohm's law, I total equal to V over R, right? So V, I total pass through 5 volts, so therefore V is 5 volt. What about R? Well, R would be the total resistance that the 5 volt has to take care of. What does it have to take care? It has to take care of this 100, right? And this 100 and this 100. But this 100 here and R2 is parallel, so it become 50. This is, like this, right? And it's in series with this 100 ohm. So therefore, my I total is 5 volt divided by 100 plus 50. So therefore, it's 33.3 milliamps. So this is 150. Okay. Then, so that means you get I total already, right? So therefore, I total, right, as in what I did right here. Okay. You may be like, what does this number come from? Okay. This number come from when I use my so-called shortcut formulas. Okay. Because I2 prime, right, would be equal to 100, right? 100 times 100 over 100 plus 100. This is your R total over R2, which is a 100 times 33.3 milliamps. Okay, so 100 cancels. Okay, so therefore you would get 100 over 200 times 33.3 milliamps, like this. Okay, so this is the case. Okay, for the answer that's due to 5 volt only. Then we have to take another voltage source. So this time we keep the 10 volt and we have to turn off VS2, which is a voltage source. So we short it as in this picture. Okay, so this is the same as picture as above, but just that 10 volt is moved to the left side of the circuit. Okay, so the idea is still the same. So therefore, current come out from 10 volt I total, right? Then it's split into the 100 ohms R2 and this 100 ohms right here. So therefore, I need to find I total first. So I total is now 10, right? So this two is in parallel now, right? So you got 50. Okay, so this 100 parallel with 100. Okay, and then in series with this 100 ohm. So your I total is 10 volt over 150, and you get this answer. This is your I total. Then I total split into I2 double prime. So I2 double prime is, of course, same thing as above. If I use my shortcut formula, I can just write down what I just wrote here. So IR2 double prime is, of course, I take the other R, which is 100, divided by the sum of the two resistors. So therefore, this is this, and you get 33.3 milliamps. So at the end, to get the final answer, what I across R2 is, you add the two together, and you get the answer. Okay, this is superposition theorem. Okay, so therefore, I hope you get some ideas. Okay, there are many problems. I may assign you in class. Right? Okay, and show you in class if we get to see each other in class or online. Thank you.